if you have a question on whatever that is being, it will be presented, you are allowed to ask because this is what you have to do. So today we're going to talk about the square and the cubes and the square root and the cube root. Are we fine? Did we cover those things?
Yes.
We covered those things for square root and cube root. Hello? Guys, let's talk. Okay, let me try to share with you your ATP on why we have to do that. If this is something that we didn't cover, you will tell me. So you can see the screen now, right? It doesn't.
Yes.
So this is your ATP. This is what you are expected to have covered. So the whole numbers we have covered this is that's even on class. We covered this and we covered the LCM, we solved the rational, and we did the commutative associated distribution, and we do this. And also we go to the integer, we did those things, is that so? The integers, multiplication, and we do the properties integer commutative, that was our last class, and we do all of this. So meaning that you guys, you are left with your formal task that you are going to write as an assignment, which is for whole numbers and for integers, if I'm not mistaken. Is that so? So it means we're going to proceed. There's someone who sent Wanga guy. Pachitanda. Not on the meeting. Our meeting.
How?
Ezvazve send and meaning not those watch Koroni.
I don't go speak what I
Okay, no problem. So it means you guys, we are moving to what we call the loss of an exponent. We're moving to what we call the loss of an exponent. Then we perform calculation involving the loss of an exponent. I think this is what we have to do for today because we are following your ATP. ATP is what it must be done on the first term because those other things are for second term. Now we are on the first term. We're on term 1. So our next things is those things for loss of exponent. Then we simplify and we do numerical and geometric partial division that we will do on the other class. So are we good? Now can you see the screen? So that we can start with our lesson. So now, as far as we're concerned, since we have covered many things, you see, your job is to practice. Your job is to practice. Your job is to practice. If you are not practicing, you will be robbing yourself, which is not good. Which is not good. So anyway, without wasting any time, let's start with the lesson of today, which is nothing but the loss of exponents. The loss of an exponent. The loss of an exponent. So when we are talking about the loss of an exponent, we must know that, when the base are the same, when there's a multiplication, what happens to the exponent? Are we good? So what do you understand about this? We understand that an exponent, can you see what I'm writing? Represent the number, an exponent represent the number of times a base is multiplied by itself. So an exponent represents the number of times a base is multiplied by itself. Let's say if we're saying a to the exponent of n, this is nothing but a multiplied by a multiplied by a multiplied by until multiplied by a in the n times. This one we don't know where n stands for any number. Are we good? So here, if we can say a to the power n, our a is stand for the base. This is the base, and this is the exponent or a power. This is exponent or power. This is the exponent or what? Or power. How we find? Hello? Guys, you must look at your mic and reply, ne? Always too, can you hear what I'm saying? Always
Yes,
too, can you hear me? So as I was saying, we have the power rule. Can we go to the next slide? Guys, if you are quiet, we'll go to the next slide and you find that you're still writing. So it's better to unlock your mic and speak. We're good. So now, we have what we call a product of power rule. We have what we call product of power rule. Product of power rule. So the product of power rule says that if we've got a to the power n multiplied by a to the power of m, this is nothing but equals to a to the power of n plus m. Says when the base are the same way there's a multiplication, we add the what? We add the exponent. So e.g., let's say we have got 2 to the power of 3 multiplied by 2 to the power of 4. So this is nothing but going to be equals to what? 2 to the power of 3 plus 4, because we add the what? The exponent, which gives us nothing but 2 to the power of what? Of 7, which is 128. Are we fine? So on number 2, we have the quotient of power rule. We have the quotient, of power rule, the quotient of power rule. So on quotient of power rule, it's like when we say we have a to the power n divided by a to the power m, then this is nothing but going to be equal to a to the power of n minus m. It says when the base are the same, where there's a division, we subtract the exponents. E.g., let's say we have, but remember, in this one where m is greater than, where n is greater than n. Are we good? Hello? So let's say as an example, 5 to the power of 6 divided by 5 to the power of 2. So this is the same as 5 to the power of 6 minus 2, which give us 5 to the power of 4, which is nothing but equals to what? 6 to 5. And we have power of a power rule. We have power of a power rule. We have power of a power rule. So, like when we're saying a to the power of n to the power of m, this is nothing but going to be equals to a to the power of n multiplied by m. So if we have an exponent, a base raised to the power n exponent, and again is raised to the power another exponent. So that exponent, it only multiplies the exponent that are inside the what? The brackets. So as an example, we have 3 to the power of 3 to the power of, let's say 3 to the power of 2, by the way, and we raise it to the power of 4. Then it simply means that this one is going to be equal to 3 to the power of 2 multiplied by 4, which is nothing but going to be equal to 3 to the power of what? Of 8. Is that so? Then when you press your calculator, what do you get? Can you press your calculator and give us the solution? Hello? Guys, can you press your calculator and unloop your mic and give us the solution?
6,561.
May I beg your pardon? Can you repeat? Ninga dobro amba. 6,000.
561.
561. Thank you very much. So this is 6,561. Can we go to the next slide? Rear color page ne photobela. So now, let's say we have, okay, we did power of a power rule. Now let's do a power of a product rule. Require it a power of a product rule. Power of a product rule. We're going to do a power of a product rule. So a power of a product rule is like when we have A multiplied by B, then to the power n. So this is the same as what? As A to the power of n, that A is going to be multiplying all the exponents, C to the power of n. So let's take an example, e.g. Let's say we have got 2 multiplied by 5, 2 multiplied by 5 to the exponent of 3. Then this is nothing but going to be equals to what? That 2 is going to be raised to the power what? 3, then multiply by. And that 5, we're going to raise it to the power 3. Are we good? Then this is nothing but what? This is nothing but 8 multiplied by what? By 125. And when you press your calculator, what do we get?
1,000.
We get 1,000. We get 1,000. So now this is nothing but going to be equals to 1,000. So can we proceed? Are you following? You guys. Okay. So number 5, we're still just introducing the loss of exponent so that when we do questions that requires loss of exponent, we will be safe. And I think more than the word safe. So let's go to power of a quotient rule. Power of a quotient rule. Power of a quotient rule. I want you guys to have a brave foundation of mathematics. So, e.g., let's say we have A divided by B to the exponent of n. This is nothing but going to be equals to this one is going to be equals to what? Hello? If you can try, if you can give it a try. This one is going to be equals to what?
AB to the power of n.
AB to the power of n. Can you try again?
Yes.
Can you try again?
I'm
Yeah,
not sure.
Hey, trying is the best. We're here to try. This is nothing but equals to what? It's nice to try. Eh? This is nothing but equals to A to the power of n divided by B to the power of n. That n is going to take all the what? The exponent. How good?
Ah,
Hello? Rerote?
yes.
Okay. So can you do example?
Eh.
So in, let's say, e.g., remember in this case, where our b is not equals to 0, our b is not. Why are we saying b is not equals to 0? Hello? Why are we saying, okay, ndingani ri tshi b yashu I songo lingana na 0? Ari ḽipule maiki ri ambe mulweli, ari ḽipule maiki ri ambe. Chilamulele. Unlock your mic and speak. Why ri tshi khou ri b yashu a i ngo tea u lingana na 0? Mufuno. Mufunwa. We don't have Mapiro Mufuno on our meeting here. Okay, all the way to why are we saying our b is not equals to 0? Guys, next time when I call your name and you don't reply, I'm removing you from the meeting. You will attend the next class. Because we can't teach people who don't speak. Bugara. Why recorded b and what you're in 0? Guys, press your calculator. Say any number divided by 0 and tell me what happens. Any number divided by 0 and what do you get?
That's error.
Yes, it's math error. That's why we're saying b is not what? Equals to 0. Are we fine? So now, let's proceed. Then e.g., oh, I took this as an e.g. This is not e.g. Our example is this one, which is following. E.g., let's say we have 4/3 all to the exponent of 2. So this is the same as what? When you check your rule, you will see that indeed this is nothing but what? Richva says that rule yashu rono ri ita ikolingana mi. Goma Bugara. Bugara.
La.
Rono ri ikolingana mi. we find that is nothing but equals to 4 to the power 2 divided by 3 to the power 2. Are we good? So now, this is nothing but equals to what? 16 over 9. Are we fine?
Yes.
Then we proceed. Recalling page now. We gotta loop your mic. We can hear that you are near the TV, if I'm not mistaken. How about the mic over with him? Thank you. So, and we have 0 exponential rule. 0 exponent, 0 exponent rule. It says a to the power 0 is equals to 1. Are we good? Where a is not equals to 0. Where a is not equals to 0. Let's take an example, e.g., let's say 7 to the power 0, this is equals to 1. So in mathematics, any number or any letter to the exponent of 0 is nothing but equals to 1. Number 7, let's say we have got a negative exponent rule. Negative exponent rule. So if we are having a to the power of minus n, this is the same as 1 over. This 1 over is the coefficient. Our 1 is the coefficient here. Here our coefficient is 1. So the coefficient is left alone on the numerator, and we say divided by a to the power of n. So when that a, it goes to the denominator. On the exponent, so we multiply by negative. We multiply by negative. So let's take an example, e.g., let's say we have got 5 to the exponent of minus 3. So this is the same as 1 divided by 5 to the power of 3, which is nothing but going to be equals to 1 over 125. Are we still together? Hello? Guys, are we still together with the loss of exponent? May you please unloop your mic and reply, everyone, all of you. Unloop your mic and test your mic, reply. Grade 9 learners. Abavule mic wabo vapindure. Here is your homework, since you don't want to answer. Next time when you join a class, you'll make sure that you answer, you guys. So in this one, so thank you for looping the mic. So now, as we were saying about this loss of an exponent, we can go to the next slide. And we said if they say simplify, we are done with the loss of exponent. If they say simplify, on number 1, they give you 2 to the power of 4 to the power of 3. So how can we simplify this one? How do we simplify? We know that they multiply the what? The exponent multiply each other is like we've got 2 to the power of 4 times 3. So which is nothing but going to be equals to 2 to the power of 12. When you press your calculator, what do you get? When you press your calculator, what do you get?
4096.
4096. So let's go to number 2. Let's say they say that square root of 9 to the exponent of 4. So this is nothing but equals to what? This is nothing but the same as 9 to the power of 4 raised to the power 1 over 2, which is equals to what? 9 to the power of 4 multiplied by 1 over 2. Then we get what? 9 to the power 2. So when you say 9 to the power 2 on the calculator, what do you get?
$81.
You get 81. So now, let's say on the next question, they state that 10 to the power of 7 divided by 10 to the power of 4. This is nothing but equals to what? This is nothing but equals to 10 to the power of 7 minus 4, which is the same as what? 10 to the power of what? Of 3. And our 10 to the power of 3 is nothing but equals to what?
1,000.
You get 1000. Then on number 4, let's say they give you cube root of 8 to the power of 6. Cube root 8 to the power of 6. So this is the same as what? 8 to the power of 6, the power of 1 over 3. And which is nothing but 8 to the power of 6 over 3, which give us what? Give us 8 to the power of 2. And what is 8 to the power of 2?
64.
What is 64? Is it difficult? Zuko kondana.
Hi.
Okay. Okay. But you have to practice, you guys. The people who are still playing here. And let's say on 5, let's say they give you 4 to the power of minus 2. So when we simplify that, it's going to be equal to, remember, 1 over and 4 to the power of what? Of 2, where 4 to the power of 2 is nothing but what? 16. Are we satisfied? Richard Otena. Hello? There we Richard Otena. Are we still together? We can't teach you by even that there are some people from Joburg, they can't even understand what is going on with their language. And this is equal to 3 to the exponent of minus 3 plus 5, which is nothing but 3 to the exponent of 2, which is equal to 9. Are we fine? Let's say we have what? Let's say we have got 7 to the power 0 plus 4 to the power of minus 1. So when we simplify this equation, we're going to have 1. Because 7 to the power 0 is 1, then plus 4 to the power of that one is 1 over 4. Then how can we write 1? We can write 1 as 4 over 4. That's 1 over 4. That's all. Or we can say we're going to find the LCM, since this one is like over 1. So this is the same as 4. 1 goes how many times? 4 times 4 times 1 is 4. Then we said plus 4 goes how many times? 1. 1 times 1 is 1. Then we get 5 over 4. Do we have any question? Do we have any question? Do we have any question? If there is no question, this is our end of the class. I will send you a homework that will be dealing with the loss of exponent. Bye-bye. So, row 13. You guys, we winning with your Uguda, which means teams.